Good day everyone. Welcome to all. My name is Sachin Ahankari, working as Assistant Professor in NRCM Engineering College in EC department. So today in this session we will see about the DC characteristics of op-amp. So there are 4 DC characteristics uh, which are available here. So I will go on the slide. So here 4 DC characteristics. The first is input bias current, the second is input offset current, the third is input offset voltage, and the fourth one is thermal drift. So input bias current, uh, this is an average of currents flowing into inverting and non-inverting input terminal of op-amp. When the inverting input terminal of op-amp is grounded and non-inverting input terminal is grounded, then at that time some small current is flowing into the input terminal of inverting and non-inverting input terminal. If IB1 is the current flowing through the inverting input terminal and IB2 is the current flowing through the non-inverting input terminal, then the average of IB1 plus IB2 divided by 2, that is average of these currents, is called as input bias current, and it is denoted by letter IB, and the value of input bias current is 500 nanoampere for the op-amp. Input offset current, it is the uh, average of it is the uh, algebraic difference between currents flowing into inverting and non-inverting input terminal of op-amp. That is mod of IB1 minus IB2 is input offset current. It is denoted by letter IIO, and the value is 200 nanoampere for input offset current. If the value is greater than 200 nanoampere, then the op-amp is of no use. The third is input offset voltage. It is a voltage that must be applied between two input terminals of op-amp to null the output. So in order to make the output voltage 0, we are applying some voltage in between inverting and non-inverting input terminal, and that DC voltage is called as input offset voltage. It is denoted by letter VIO, and the value is 6 millivolt DC maximum. The fourth parameter is thermal drift. So up till now we have considered that the input bias current, input offset current, and input offset voltage. So these parameters they are constant, but in practice these parameters are not constant, and these three parameters, that is input bias current, input offset current, and input offset voltage, these three parameters change with change in temperature, change in supply voltage plus VCC and minus VEE, and with time. So these three parameters are going to change with these three parameters, that is changing temperature, changing supply voltage, and time. So if I go for the first drift, thermal drift, that is thermal voltage drift. So it is defined as the average of change of input offset voltage per unit change in temperature. It is called as input offset voltage drift, and it is the value at room temperature for the input offset voltage is 0, and as you are going to increase the temperature, the input offset voltage is going to increase, and if you are going to decrease the temperature, then it is going to decrease. It is expressed in microvolt per degree centigrade. The drift is not constant, and it is not uniform over specified operating temperature range. The value of input offset voltage may increase or decrease with the increasing temperature. And the next drift is input bias current drift. It is defined as the average rate of change of input bias current per unit change in temperature. It is measured in nanoampere per degree centigrade or picoampere per degree centigrade. these parameters vary randomly with temperature, and they may be positive in one temperature range and they may be negative in another temperature range. So this is a graph of input bias current versus temperature. So at the room temperature, the input bias current is 20. As you are going to increase the temperature, input bias current is going to decrease, and as you are going to reduce the temperature, input bias current is going to increase. So this is a not constant parameter, it is going to change with the temperature, and it is called as a input bias current drift. And the third parameter, that is input offset current drift. So it is average rate of change of input offset current per unit change in temperature. It is measured in nanoampere per degree centigrade or picoampere per degree centigrade, and these parameters vary randomly with temperature. That is, they may be positive in one temperature range and negative in another temperature range. So here the value of input offset current at room temperature, it is 0. As you are going to increase the temperature, input offset current increases, and as you are going to decrease the temperature, input offset current decreases. So these parameters are going to vary with the temperature. That's why they are called as a thermal drift, or it is a three types of drifts are available depending on the three parameters, that is input offset voltage, input bias current, and input offset current. So uh, the, these are the drift, and these are the DC characteristics of op amp. So in the next lecture we will see AC characteristics of op amp. Thank you.